Welcome to my next video, linear equation in two variables, practice set 1.3. Before going to the practice set 1.3, we will discuss about determinants and Cramer's rule. First of all, we will see what is the determinant. If A, B, C and D are any four numbers and the value of AD minus BC is represented by a set of two rows and two columns in between two vertical lines, then such representation is called as determinant of order 2 because it contains two rows and two columns. Let me solve one problem. How to find the value of given determinant? Write down the given determinant is equal to the product of first row's first element and second row's last element. Write down 4 multiplied by 6 minus second element of the first row multiplied by first element of second row, that is 3 multiplied by 5 is equal to 4 into 6 24 minus 3 into 5 is 15. 24 minus 15 is equal to 9. Okay. Now we have to solve such determinants in Cramer's rule. Now we'll see Cramer's rule. To solve simultaneous equations by using Cramer's rule, it is important that these simultaneous equations are in the form a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Then we have to prepare three determinants d, dx and dy. How they are prepared, we will see. Now first determinant d. The coefficients of x and y of both equations are taken so that the first determinant d we will get like this. Now second determinant dx is prepared by taking constants of first and second equation instead of x coefficient and keeping y coefficients as it is, like this. Okay. The dy is prepared by taking x coefficient of both equations as it is and taking constants of both equation instead of y coefficient by using Cramer's rule. The value of x is calculated by the formula x equal to dx upon d and y is calculated by the formula y is equal to dy upon d. Thus, Cramer's rule is used to solve simultaneous equation using determinants. Okay. Now here comes practice set 1.3. Question number 1. Fill in the blanks with correct number. Here we have to find out the value of this given determinant. Given determinant is equal to, as we have seen earlier, first number of the first row is multiplied by second number of second row, that is 3 multiplied by 5 minus second number of first row multiplied by first number of second row, that is 2 multiplied by 4 is equal to 3 5s are 15 minus 2 4s are 8 is equal to 15 minus 8 is equal to 7. Question number 2. Find the values of following determinants. First determinant is equal to product of first element of first row multiplied by second element of second row, that is minus 1 multiplied by 4, minus second element of first row multiplied by first element of second row, that is 7 multiplied by 2 is equal to minus 1 into 4 is equal to minus 4 minus 7 into 2 14 minus 4 minus 14 is equal to minus 80. Now we'll see second determinant is equal to 5 multiplied by, are you right? 0 minus 3 multiplied by minus 7 is equal to 5 multiplied by 0, it gives 0 minus 3 multiplied by minus 7 minus 21. Minus of minus 21 becomes plus 21. Good. Third determinant is equal to, we have to perform the cross multiplications as earlier. 7 upon 3 multiplied by 1 upon 2 minus 5 upon 3 multiplied by 3 upon 2 is equal to 7 ones are 7, product of numerator divided by product of denominator. 7 ones are 7, 3 twos are 6, 7 upon 6 minus second multiplication 5 threes are 15 in the numerator, 3 multiplied by 2 is equal to 6 in denominator. As we have to perform here the subtraction of fraction having denominator same. Keep this denominator as it is 6 and we have to perform subtraction in numerator. 7 minus 15 gives minus 8 upon 6. Divide it by 2, we get 2 4s are 8, 2 3s are 6. That means minus 4 upon 3. Now question number 3. Solve the simultaneous equations by using Cramer's rule. Problem first. 3x minus 4y equal to 10. 4x plus 3y equal to 5. Now there is one note. Confirm that both equations are in the form ax plus by equal to c. Answer. 3x minus 4y equal to 10. First equation. 4x plus 3y is equal to 5. Second equation. Both the equations are in the form ax plus by equal to c. Now we have to find out the values of three determinants d, dx and dy. First of all, we'll see determinant d is equal to coefficient of x and y of both equations, like this. Now we have to find out the value of this determinant as earlier we have seen is equal to 3 multiplied by 3 minus 4 into 4 is equal to 3 into 3 9 plus 16 is equal to 25. Next dx is equal to, we have to take here instead of coefficient of x, that is 3 and 4, we have to take c1 and c2 constants from equation 1 and 2, like this. And keep coefficient of y as it is, like this. And we have to find out the value of this determinant. 10 multiplied by 3 minus 4 multiplied by 5 is equal to 10 3s are 30, minus become plus, 4 5s are 20 is equal to 50. Now we have to prepare determinant dy by taking x coefficient as it is and replacing y coefficients of equation 1 and 2 by constants c1 and c2. After that, we will find the value of dy as earlier we have seen. 3 multiplied by 5 minus 10 multiplied by 4 is equal to 3 5s are 15 minus 10 4s are 40. That comes 15 minus 40 is equal to minus 25. After that, by Cramer's rule, x is equal to dx upon d is equal to 50 upon 25 is equal to 2, and y is equal to dy upon d is equal to minus 25 upon 25 is equal to minus 1. Thus, the solution of given simultaneous equation is x equal to 2 and y is equal to minus 1. Question number 2. 4x plus 3y minus 4 is equal to 0 and 6x is equal to 8 minus 5y. Now look at these equations. These are not in the form ax plus by is equal to c. Therefore, we have to rearrange these equations in the form ax plus by equal to c, and that is our note. Rearranging these two equations, we get 4x plus 3y equal to 4, first equation. 6x plus 5y equal to 8, second equation. Now, we have to find out three determinants d, dx and dy. Let's start with first determinant. D is equal to, take the coefficient of x and y from both equation and write them like this, and finding the value of this determinant, we get 4 into 5 minus 3 into 6 is equal to 4 5s are 20 minus 18 is equal to 2. Now dx is equal to, instead of x coefficient, take constant c1 and c2 and keep y coefficient as it is. We get 4 into 5 minus 3 into 8 is equal to 20 minus 24 is equal to minus 4. Next determinant dy is equal to, keep x coefficient as it is, and instead of y coefficient we have to write the constants c1 and c2. We get 4 into 8 minus 4 into 6 is equal to 32 minus 24 is equal to 8. By Cramer's rule, x is equal to dx upon d is equal to minus 4 upon 2 is equal to minus 2, and y is equal to dy upon d is equal to 8 upon 2 is equal to 4. In this way, the solution of given simultaneous equation is x is equal to minus 2 and y is equal to 4. Okay. Fourth problem is assignment for you. We'll solve the fifth problem. 4m plus 6n is equal to 54 and 3m plus 2n is equal to 28. Now consider this note. Both equations are in required form ax plus by equal to c. So there is no need of any rearrangement. Here variables m and n are used instead of x and y. So we have to find out value of d, dm and dn determinants. Now d is equal to, take the coefficients of m and n, and the value of d is calculated as earlier we have seen. 4 into 2 minus 6 into 3 is equal to 8 minus 18 is equal to minus 10. Now dm is equal to, replace the coefficient of m by constant 54 and 28. Keep n coefficient as it is. Then we get 54 into 2 minus 6 into 28 is equal to 54 2s are 108 minus 28 6s are 168 is equal to minus 60. Now dn is equal to, keep m coefficient as it is. Replace n coefficient with constant and find the value of dn is equal to 4 multiplied by 28 minus 54 into 3 is equal to 112 minus 162 is equal to minus 50. By Cramer's rule, m is equal to dm upon d is equal to minus 60 upon minus 10 is equal to 6. N is equal to dn upon d is equal to minus 50 upon minus 10 is equal to 5. Therefore, solution of given simultaneous equation is m equal to 6 and n is equal to 5. Okay. Now the last problem. 2x plus 3y is equal to 2 and x minus y upon 2 is equal to 1 upon 2. Note, both equations are in required form. Ax plus by equal to c. So there is no need of any rearrangement. Answer. 2x plus 3y is equal to 2 first equation. X minus y upon 2 is equal to 1 upon 2. Now we have to find out the values of d, dx and dy as we have seen earlier. D is equal to, take the coefficient of x and y, we get like this, is equal to 2 into minus half minus 3 multiplied by 1 is equal to, here 2 multiplied by minus half, it gives minus 1 minus 3 is equal to minus 4. Now dx is equal to, replacing x coefficient by constant, that is 2 and half, and keeping y coefficient as it is, we get 2 multiplied by minus half minus 3 multiplied by half is equal to minus 1 minus 3 by 2 is equal to minus 5 by 2. dy is equal to, keep x coefficient as it is and replace y coefficient by constant. It gives 2 multiplied by half minus 2 multiplied by 1 is equal to 1 minus 2 is equal to minus 1. By Cramer's rule, x is equal to dx upon d is equal to minus 5 by 2 upon minus 4 is equal to 5 upon a. Y is equal to dy upon d is equal to minus 1 upon minus 4 is equal to 1 upon 4. Therefore, solution of given simultaneous equation is x equal to 5 upon a and y is equal to 1 upon 4. Four.